Class, in this video we continue our discussion in section 6.6 in your note packet on the area between two curves, and we are going to pick up the discussion on page 94 of your note packet with example 2. And in this example you're instructed to find the area of the region bounded by the graphs of the equations y equals x squared plus 2 and y equals minus x plus 2. So here in the graph on the left, in the blue here, this blue parabola is the equation y equals x squared plus 2, and then this green line is the equation y equals minus x plus 2. And you can see right here, right, there's a slither of area sandwiched between those two curves. What is the size of that area? Well, first you will notice that the two curves intersect at x equals minus 1 and at x equals 0. So A is equal to minus 1 in this problem and B is equal to 0. The upper function or upper equation for this area here is a straight line, y equals minus x plus 2, and the bottom equation is the parabola y equals x squared plus 2. So upper equation minus lower equation in this example is equal to minus x squared, right? You take minus x plus 2 and then you subtract x squared plus 2 and you get minus x squared. So the area sandwiched between the straight line and the parabola is equal to the definite integral from minus 1 to 0 of minus x squared with respect to x. The antiderivative of minus x is minus 1/2 x squared. The derivative, or excuse me, the antiderivative, so I hope I said antiderivative of minus x is minus 1/2 x squared, and the antiderivative of minus x squared is minus 1/3 x cubed. Now, to make calculation of the area, right, substituting the upper and lower limits of integration, I'm going to factor out this minus sign from these two terms, which is the same as factoring out a minus 1, and I have the negative of the quantity 1/2 x squared plus 1/3 x cubed. I did that correctly because if you distribute the minus sign inside the parentheses, right, the sign of the two terms get changed to minus. All right, now the limits of integration are minus 1 and 0. So we put into upper limit of integration 0 and for x, and you can see each of those terms inside the parentheses will equal 0, and so we'll just have 0 plus 0. And then we subtract, and minus a minus is positive. And then we put in the lower limit of integration for x, and we have 1/2 times minus 1 squared plus 1/3 times minus 1 cubed, and this first term inside the parentheses is equal to 1/2. The second term is equal to minus 1/3, and 1/2 minus 1/3 is equal to 1/6. So the size of that area in that sandwich between straight line and parabola is equal to 1/6 square units. Now you should note that that makes sense because each of these squares in the graph here equals 1 square unit, right? Each square is 1 unit wide, 1 unit tall, and so the area of a square is 1 square unit, and this area between the straight line and the parabola is inside 1 square, which has an area of 1 square unit. So that we got an answer greater than 0 and less than 1 makes sense. All right, class, now let's take a look at example 3 down below. And we're going to find the area of the region bounded by the graphs of the equations y equals 6 minus x squared and y equals x squared plus 4. So the graphs of each of these equations is a parabola. So here the parabola in blue is the equation y equals x squared plus 4, and then the parabola in green is the equation y equals 6 minus x squared. And so we got to find the size of this area in pink. sandwiched between the two parabolas. Well, you'll notice that two equations, right, the graphs of the two equations intersect at x equals -1 and at x equals +1. So A is equal to -1 and B is equal to +1 in this case. So the upper equation is y equals 6 minus x squared. The lower equation is y equals x squared plus 4. And when we do upper minus lower, we get 2 minus 2x squared. So when we take the upper equation and then subtract from it the lower equation, we end up with 2 minus 2x squared. So the area in pink here is equal to the definite integral from -1 to 1 of 2 minus 2x squared. The antiderivative of 2 is 2x. The antiderivative of minus 2x squared is minus 2/3 x cubed, and the limits of integration are -1 and 1. So we put in the upper limit of integration 1 in for x, and when we do that, 2 times 1 is 2, minus 2/3 times 1 cubed is minus 2/3, and then we subtract and put in the lower limit of integration. And because there are two terms here, right, when you subtract, put it in parentheses. Otherwise, you'll change the sign of the first term, but not the second term. And so when we put in -1 for x, we have 2 times -1 minus 2/3 times -1 cubed. And now this is an arithmetic expression. You got to follow the order of operations. And when you do that, this arithmetic expression is equal to 8/3. And so the size of this area in pink is equal to 8/3 square units.